So my project is clustering stocks based on price data. So the purpose of my project is to create an algorithm that is able to group stocks together based on correlation. So preferably stocks within a group will be more correlated to each other than stocks outside of that group. So the reason why you want to do this is if you're interested in finance or you're a stock modeler, you have a stock that you're interested in, you also have another stock that you understand maybe a little bit better, but you know that's correlated to the stock that you're interested in, then you can attribute changes in the stock that you understand to the stock that you're interested in. So I started with just getting a bunch of closing price data. So I got this closing price data from the healthcare and energy sectors. Why I chose those sectors will be discussed in the future. But this is time series data, and so as we've seen in the past, that we're going to feed this time series data through an SCFT, and then also through L2 normalization, because the actual price data doesn't really matter. It's more so just the changes in price. The output of this is then fed into a distance matrix algorithm, which essentially assigns each element in the distance matrix to the distance between stock I and stock J, and that distance is calculated by the subsequence DTW cost, which is also seen in the past. This distance matrix then fed into a hierarchical clustering algorithm, which is able to group stocks based on distances using the subsequence DTW cost, and it will eventually be able to say that each stock belongs into one of two groups. The groups that each stock belongs into will then be compared to true labels, and that set of true labels will also be discussed in the next slide. So I first gathered 1,500 days of daily and closing price data for stocks in the healthcare and energy sectors. So why I chose the healthcare and energy sectors that they seem to be largely uncorrelated compared to other pairs of stocks. And so if our clustering algorithm is able to group stocks in healthcare together and is able to group stocks in energy together, then it would have done a pretty good job because the clustering would have matched the actual true labels of the healthcare and energy sectors. The next step was compute the SCFT on each of the time series. I then computed the DTW cost function so that I can create the DTW DTW distance matrix. I then use SciPy to cluster the stocks using this distance matrix, and then after the clustering algorithm was created, I would then able to assign labels using the clustering for each of the stocks, and then this set of labels was compared to the true set of labels for which are the sectors using adjusted rand index. So my results. So on the left, you can see an example of the hierarchical clustering and how it splits up the set of stocks into two different clusters. And so if our algorithm performed well or performed as expected, then you would expect the green to be consistent of entirely healthcare or energy stocks, and the blue to be consistent entirely of the opposite. So it turns out that our algorithm did not perform according to expectations. On the top, you can see that a value of negative 0.025 was achieved when comparing the clustering labels to the true labels of the sector. And you expect a value of 0 when you just have randomly assigned labels, and a value of -1 or 1 when there is no difference between the labels you assign and the true labels. So ours is pretty close to 0, much more close to 0 than it is to 1. And on below is just an example of randomly assigned labels and what that score would be. And as you can see, it's close to 0, but our score is a little bit closer to 1 or -1 than it is to than the other score is. So the reason why this algorithm could have performed poorly was that maybe the assumption that the stocks in the sectors are uncorrelated was wrong, and also that maybe the algorithm was at fault. Both of these are probably at play, but I do think that the assumption that the two sectors are uncorrelated enough for the correlation within them to outshine the correlation between them. I do think that that is reasonable to question that assumption. And so my future work will be based around getting rid of that assumption. So I'll first try to test the effectiveness on similar trends, so that I can handpick things that I know are correlated rather than just guessing that this set of stocks are correlated. And so I can maybe like choose like two linear things that I know linear, and the two something that else that looks completely wacky, and I know that the two linear things are correlated, whereas the other wacky looking thing isn't. And then run my clustering algorithm on that, and then see if the clustering again matches the true labels of what I know are correlated to each other. Also, I could after that, and I wanted to continue with stock data, I could try to find better true labels for the stocks, maybe based on some more research rather than just saying that uh, stocks in the sector are going to be more correlated to each other than outside of the sector, um, and that will just be better for validation and determine whether or not my algorithm is actually performing well.